Welcome to True Projects. In this video, we will be explaining about smart internet probing scanning using adaptive machine learning. Introduction. The Smart Internet Probing project aims to address the issue of resource wastage and excessive bandwidth consumption caused by probing non-functional servers while attempting to access various services running on the internet. Traditionally, clients perform port scanning to determine whether servers are active or not, enabling successful connections. However, this project can be highly efficient, especially when dealing with a vast number of servers and services. To overcome this challenge, the project leverages the power of adaptive machine learning algorithms to predict the availability of servers based on their shared features, optimizing the scanning process and conserving valuable network resources. Objective. The objective of the Smart Internet Probing project is to utilize adaptive machine learning algorithms to predict the status of servers based on shared features, enabling efficient port scanning. By evaluating popular algorithms like support vector machine, logistic regression, decision tree, random forest, deep learning neural network, gradient boosting, and extreme gradient boosting, the project aims to minimize resource wastage and bandwidth consumption. The focus is on achieving a high true positive rate for accurately classifying an active and inactive servers. Additionally, the project explores both parallel and sequential scanning methods to optimize computational efficiency. Ultimately, this initiative aims to enhance network resource utilization and improve internet service access while reducing unnecessary probing efforts. These are the requirements needed for the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. Coming to the algorithms, we have used logistic regression. Logistic regression is a classification algorithm used in project to predict the probability of servers being active or not active based on shared features, making it suitable for binary classification tasks like determining server availability. Next one is support vector machine. SVM is employed in the project for its ability to efficiently classify servers into active and inactive categories by finding optimal hyperplane, separating the two classes and handling nonlinear data with the use of kernel trick. Next one is decision tree. Decision tree are used to create a model that predicts server status based on hierarchical decisions made on shared features, making it interpretable and suitable for both categorical and numerical data in the project. The next one is random forest. It is an ensembling learning method that combines multiple decision trees to improve prediction accuracy and reduce overfitting in the project's port scanning process. Fifth one is gradient boosting. Gradient boosting is utilized to build strong predictive models by combining weak learners sequentially with each new learner, correcting the errors of its predecessor, resulting in more accurate predictions for server availability. Next one is extreme gradient boosting. Extreme gradient boosting is an optimized version of gradient boosting that improves computational efficiency and prediction accuracy, making it top performing algorithm in the project's objective of efficient port scanning and resource management. Seventh one is deep learning. Deep learning neural network are used to learn intricate patterns and relationships in the complex data for accurate classification of server availability, offering flexibility and scalability to handle large-scale data sets. Coming to methodology, we have designed these modules. In first module, upload internet port scan dataset. Using this module, we will be uploading dataset to application and then display types of ports found in the dataset. Next one is dataset pre-processing. Dataset contains non-numeric and non-numeric data, and machine learning algorithms only accept numeric data. So by using this module, we will encode non-numeric data into numeric and then split dataset into train and test, where application use 80% dataset for training and 20% for testing. Next one is run logistic regression algorithm. Using this module, we will train logistic regression by using 80% data and then apply regression model on 20% data to calculate true positive value. Then the higher true positive rate is better the algorithm. Similarly, we will be training decision tree, random forest, gradient boosting, extreme gradient boosting, deep learning neural network and support vector machine, and then calculate its true positive rate. Last one is comparison graph. Using this module, we will be plotting true positive rate graph of all the algorithms. Coming to the execution, first open the code folder. So this is the code folder, and this is the dataset file. Using this dataset, we will be building all the models, and this is the model file. In this, we have .h5 file stored in it, which contains the algorithm information. These .h5 files can be loaded into the project code during runtime to utilize the train models. Now, and these two are the main code files, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. Now double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. Click on the button Upload Internet Port Scan Dataset. Select the data and click on Open. Here we can see dataset is loaded. In the dataset, we can see it contains numeric and non-numeric data, so we need to encode it to numeric by applying data preprocessing. Here in the graph, x-axis contains port values and y-axis contains count of each port in the dataset. Now close the graph and click on Data Preprocessing button to process dataset. Here data is preprocessed. In this, we have splitted the data into train and test. In train, we have 1,54,652 records, and in test we have 38,663 records. Now click on the button Run Logistic Regression Algorithm. This is the confusion matrix of the logistic regression algorithm. Close this, and this is the true positive rate of logistic regression. Now click on the button Run SVM Algorithm. This is the confusion matrix of support vector machine algorithm, and this is the confusion matrix. In this, x-axis represent predicted labels and y-axis represent true labels. And here we can see SVM algorithm's true positive rate. Now close this graph. Click on the button Decision Tree Algorithm. Here, this is the confusion matrix of decision tree algorithm. Close this. And this is the true positive rate of decision tree algorithm. Now click on the button Run Random Forest Algorithm. This is the confusion matrix of random forest algorithm, and this is the random forest true positive score. Now click on the button Run Gradient Boosting Algorithm. Close this graph, and here is the true positive rate of gradient boosting algorithm. Now click on the button Extreme Gradient Boosting Algorithm. This is the confusion matrix of Extreme Gradient Boosting Algorithm. Close this. And this is the extreme gradient boosting true positive rate. Now click on the button Run Deep Learning Algorithm. This is the graph, which is confusion matrix of deep learning neural network, and this is the true positive rate of that algorithm. Now click on the button Comparison Graph. Here on x-axis we can see algorithm names, and on the y-axis we can see true positive rate. Among all the algorithms, Extreme Gradient Boosting Algorithm is performing well. Close this graph. Now close this UI. Conclusion. The Smart Internet Probing project evaluated various machine learning algorithms for efficient port scanning to determine server availability. After thorough analysis, it was found that extreme gradient boosting demonstrated superior performance among all the algorithms. Its ability to achieve high true positive rate proved invaluable in accurate predicting whether servers were running or not, minimizing false negative and reducing resource wastage and bandwidth consumption. As a result, extreme gradient boosting is recommended as the best suited algorithm for the task of predicting server status, thus optimizing the new network's resource utilizing and improving overall internet service accessibility.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.